Good morning, students. Myself, Dr. BADI ALEKHYA, Assistant Professor, Department of Artificial Intelligence and Machine Learning, R.M.D. Engineering College. Today, we are going to discuss about the concept pure optimization. What is the need of optimization in deep learning? What are the different types of algorithms and procedures we have to follow when we are implementing optimization in the deep learning models? Let us start the session. What is an optimization in deep learning model means we have to find out in a single word. If you want to tell that what is the need of optimization means, when we train deep learning mainly trained complex models with vast data set, if the data is very vast, the optimization algorithms will be helpful to find out the optimal set of parameters for those models to provide or enhancing the accurate results of the model. That is the purpose of using optimization in deep learning model. In single word, you have to understand what is the need of optimization in deep learning model. Means optimization algorithms will be helpful for us to select the parameters which will help, because it's a complex model is having the vast data set and vast set of parameters. Among that, we have to choose the best parameters to provide accurate results in the uh, end of the network. Means we have to choose optimization algorithms. So what are the fundamentals of optimization algorithms means, initially we discussed that when we can say that the network is the model is producing the accurate results means if the loss function is less. What is the need of this optimization algorithms when we are calculating the loss function means, we after measuring the performance of the model by calculating the differences between the predicted and the actual value. So the predicted with the difference between the predicted and the actual values, we called it as loss function or error function. Based on that only, the gradient descent algorithms reacted to adjusting the model parameters to minimize the loss functions in the by moving in the direction of negative gradient. That means here the weights and bias also called it as parameters. These parameters are adjusted based on the loss functions. That's why under optimization algorithms, gradient descent also plays a very important role. And after that, learning rate, especially in case of recurrent neural networks, we are considering this learning rate parameter. What's this learning rate parameters will do means, at each step of iteration of gradient descents, it will be find out that how it is influencing the steep and stability of convergence. For example, if we are considering too low learning rate means, that means too small amount of learning rate means, it is going to decreases the performance of the model. If you are getting high amount of, that means high range of learning rate means, it will leads to instability of convergence. That's why in middle, based on the model, we have to accurately decided that what's the learning rate. It will be decided by optimization algorithms. That's why optimization algorithms plays a vital roles to decide that type of optimal parameters we have to consider to increasing the accuracy of the model. And then come to the convergence means, already I insisted that in the learning rate, if you are based on your learning rate selection, we only it can decided that it will be moving into the faster convergence or lower convergence, or otherwise it's stuck into the middle of the networks. That impact also will be based on how we are going to selected the optimal parameters in the given network. We have gradient based optimization methods. One is gradient descent, stochastic gradient descent, and momentum. Gradient descent, when we are, it is very simple and widely used optimization method. But what's the problem inside it? We have to stuck under local minimum, and it will be slow for larger data set. So to avoid this problem, stucking in local minimum, we are considering momentum. The momentum will, considering incorporating the previous updates, helps to escape from local minima. And coming to the stochastic gradient descent algorithm or method, if we are using, instead of considering the entire set of data, we are considering random set of data for each update, making it faster when compared to gradient descent. But it's also a less stable technique. And when we are considering the stochastic optimization, we have three types of techniques. One is ADAM, second one is ADA grade, and third one is RMS props. First, we discuss RMS props. Here, it is addressing the issues of dimensioning and learning rate by instead of considering a squared gradients, here considering average of squared gradients. The advantages of RMS props we are going to combine with momentum, and we are implementing a stochastic optimization technique called ADAM. Most of the models we are considering ADAM because it's having the combined advantages of both momentum and RMS props. When coming to the ADA grade, mainly we are used in recurrent neural networks to adjusting the learning rate based on previous or past updates for promoting fast convergences in case of test analytics and all. We have three types of constraint optimization. One is regularization, and second one is equality constraints, and third one is inequality constraints. So if you want to penalize the parameter values, which is leads to overfitting, we are considering two types of regularization techniques. One is L1 and another one is L2. L1 represents lasso and L2 represents ridge. ridge. And coming to the equality constraints, where the network will need fixed weights and predefined outputs to enforce the relationship between the parameters in optimization. The given model consider equality constraints. If you are bonding with non-negative weights and bounded activation functions to limit the parameters to a specific range, we are using inequality constraints. And what is the need of hyperparameter tuning? The hyperparameter tunings will be helpful to select the best optimal parameters for the given model. If you are considering grid search, CV, random search, these are the sum of the hyperparameter tuning techniques. For example, if you are considering convolutional neural networks, number of filters, strides, pooling function, which function you are going to use, what type of activation functions we are considering. These are some of the hyperparameters we are used under the optimization of the given model. And coming to the recurrent neural networks, the learning rate, step size, this will deciding that the performance of the given model. And some of the challenges, these are the some of the optimizational challenges in deep learning: local minimum, saddle points, vanishing or exploding gradients, and high dimensional landscapes. So local minimum in gradient descent algorithm, we saw these problems. For small larger data sets, the solution will struck at local minimum, and the saddle points, it is not going to fix the solution either at the local minimum or at the global minimum. Makes the points gradient is equal to 0. When coming to vanishing or exploding gradients, uh, gradients becomes extremely small or large when at the time of training, make us difficult to update the parameters in a efficient manner. That means it's not to be too small or it's not to be too large when we are training the parameters in the given networks. When we considering the complex loss surfaces, it's also a challenging part in the optimization of deep learning. That's all students for the today's session. We will meet with some other new concepts in the next session. Thank you all.